Hey guys, Mr. Jenkins here again. This will be the 8-4 notes for Algebra 2, so go ahead and get right to it. So this will be, like I said, section 8-4, title Rational Expressions. Learning target, I can simplify, multiply, and divide rational expressions. And then there's a definition for what a rational expression is. I'm going to focus more on the rules here, what we need to do, the steps we need to follow. Step 1, if possible, factor the numerator and the denominator. So kind of just like what we did in 8-3, if we have a quadratic or higher degree expression, then we want to factor that out. Divide out common factors, also known as cancel common factors. Simplify. And then we also list our restrictions, also known as the domain. So we will jump right into example A, where we have x squared plus 3x plus 2 over x plus 2. So obviously our numerator is a quadratic. So we'll start by writing that as the product of two binomials, if possible. So what multiplies to 2 but adds to 3? That'd be 2 and 1. So I'm going to rewrite the top as x plus 2 times x plus 1. And that's over x plus 2. Don't really need the parentheses since there's only one factor underneath, but makes it look more obvious maybe that those are our common factors. So x plus 2 over x plus 2 cancels. That leaves us with x plus 1 over 1, which really you don't need to write it that way, just be x plus 1. And then we go back to the original expression for the restrictions. Right there, if we set x plus 2 equal to 0, we get x equals negative 2. So that is our restriction, or our point of discontinuity. So we can't have where x equals negative 2. And if you notice that sweet little voice in the background, that's just my daughter trying to go to sleep. So hopefully that doesn't bother you too much. Next example I'm going to cover is C. As you probably picked up on an 8-3, I'm just doing some of these, and then you can see all of them worked out on the filled out notes. So C, we want to, on the bottom, it's not necessarily obvious what we need to do, but we need to remember if our lead term written in standard form is negative, we want to factor out and make that positive. So we're going to rewrite this as, leave the top the same, 3 times the quantity x minus 3 over, and again, we're going to factor out that negative and make it x minus 3. So negative 1 times x minus 3 would be another way to think of that. Now we see we do have that common factor. So then we have 3 over negative 1. That just simplifies to negative 3. So if we graph this, if we put this in our graphing calculator, we would just see, y equals negative 3 would be just a horizontal line. We do have to consider this restriction, though. So if we set x minus 3 equal to 0, we would get x equals 3. So x cannot be 3. All right, going on down to example E, has a little bit of a different look there. Couple variables in that one. So for these, I kind of think of, this is more of an exponent rule problem to me. Remember when we divide same bases, such as x cubed over x squared, we subtract those exponents. So 24 over negative 6 would be negative 4. X to the 3 minus 2 gives me x to the 1. And then y to the 2 minus 3 gives me y to the negative 1. And then remember, we want to express that as 1 over y to the 1. So we would do one more step there to make it negative 4x over y to the 1, or just y. And then we go back here for our restrictions. What can we plug in to make x, to make the 0 for x? 0. Same for y. So this one actually has two restrictions. X can't be 0. Also, y can't be 0. All right, and then the last one I'm going to do on this page is example H. So again, on top, we don't want that lead term to be negative. So we want to write that as the product of -1 or just negative times positive 8x minus 10. Sorry, I did that wrong because they have another common factor, not just -1. We can factor out a 2 from both of them. So we want to factor out a -2, not just a -1. And then that would make my lead factor positive 4x, and then my other factor -5. The denominator is the difference of squares. 16x squared is a perfect square. 25 is a perfect square. So think a plus b times a minus b. A is the square root of that term, so 4x. B is the square root of that term, so 5. So we'd have 4x plus 5 times 4x minus 5. All right, so what are we left with? Up top, -2. So we have -2 over 4x plus 5. Our restrictions, we kind of look at this step of the problem to see what our restrictions would be. If we solve this for 0, we would get x equals -5 over 4. This one we get positive 5 over 4. So we just say x can't be positive or -5 over 4. Or 1.25 if you like. All right, the last point I was going to make here is that we can use our graphing calculator to kind of check. So how might we do that on a problem like this? Well, what I would do is punch in the unfactored form. Need to use parentheses there. 10 minus 8x, close parentheses, over, sorry, my screen's a little messed up there, parentheses 16x squared minus 25, close parentheses, and then punch it in how we think, what we think the answer is. So that'd be -2 over 4x plus 5. And then you can look at the graph. I like to look at the table. And so we can kind of see that, 1 goes to the same thing on both. And when y1 and y2 match up like you see right there, you know that we've probably done that correctly and should be good to go the whole way through. So that's an example of a way that you can check your answer. You can also check by looking at the graph as well, and you should see one graph. Moving on to the back side. Now we're going to add in just an operation, okay? So we're going to be multiplying an example 2, and just a reminder, A over B times C over D is just AC over BD. So we want to, again, just start out by factoring, okay? Obviously, we got a lot of quadratic stuff going on, so we want to kind of simplify this as much as possible. So looking here, we can factor out a 2. I'm going to write that as 2 times the quantity x minus 4. And that's over a difference of squares, so that'd be x plus 4 times x minus 4. And then up over here, what multiplies to 4 adds to 5. That'd be 4 and 1, so x plus 4 times x plus 1. And then right here, that's going to be multiplies to 16, adds to 8, x plus 4 times x plus 4. All right, so now we'll start to cancel. So remember, it's this times this over this times this. So we can cross cancel and cancel ones that are directly over each other as well. So that my first cancellation is going to be these two, x minus 4 and x minus 4. Also x plus 4 and x plus 4. And then there's nothing really to go with this x plus 1, so no other cancellations we can make. So now we're kind of multiplying. So we would take 2 times the quantity x plus 1. So I'm going to go ahead and distribute there and write that as 2x plus 2. On MathXL, if you write it as 2 parentheses x plus 1, I'm not sure if it's going to count that as correct or not. It may. You can just play around with that and try that. And that's over x plus 4 times x plus 4, or also known as x plus 4 squared. Or you could write it as x squared plus 8x plus 16. So lots of different ways you could write that there. For my restrictions, I'm looking at this step, right? So anything that's going to make any of these a 0. So negative 4 would make that a 0, positive 4 that, and then negative 4 for both of those. So all of our restrictions are just positive or negative 4. All right. And then B's done on the notes. We'll skip down to C. C is as well, but I'd like to work some of these out where I can give you some explanation. So again, we'll start by factoring. Right here is going to factor out into x plus 3 times x plus 2. Nothing, no common factors here, so that's just going to stay x minus 5. I like to put parentheses around them. Don't necessarily have to. Difference of squares here, so x plus 5 times x minus 5. And then here we would have x plus 3 times x plus 1. All right, now we're going to see what we can cancel. This x plus 3 can cancel with that x plus 3, so cross canceling there. No x plus 2 down there, so is there an x plus 5 down here? No, but there is an x minus 5, so we can cancel those two out. So we would have x plus 2 times x plus 5. Over the quantity x plus 1. As far as how to enter your answer on MathXL, I would try it like this and just see if it accepts it. If it does not accept it, then that means you need to multiply that out. So I'll show you the other way you can write that answer. But just in case it will accept it that way, I'm going to leave it that way. So now to my restrictions, positive 5, negative 3, negative 1. So all of those would make give us an error if we plug that into our calculator. Okay, and then like I said, if MathXL won't accept it that way, then we'll go ahead and multiply this out. So we'd rewrite that as x squared, and then you'd have 5x plus 2x, so plus 7x, plus 2 times 5 is 10, and then nothing to change on the bottom. So if it won't accept it this way, it's probably wanting you to take it that extra step. All right, and then the last one I'm going to show you is a division problem. And then, so the main thing to remember here is that we use, same, change, flip, multiply by that reciprocal. Okay, still want to start out by factoring if possible. So on A, I'm going to factor this out to x plus 4 times x plus 1. Difference of squares for our next one. Actually, sorry, I'm going to do this first. So that's going to be x plus 4 times x minus 3. And then difference of squares there, so x plus 1 times x minus 1. Just to save yourself a little writing here, you might want to go ahead and just do your same change flip while you're factoring, but uh, anyways, I'm going to show it a little bit lengthier here. And then out of these two, I can factor looks like a 2x. So 2x times the quantity x minus 3. All right, now I'm going to go ahead and do my same change flip. So x plus 4 times x plus 1 over x plus 4 times x minus 3. Also, to save a little bit of work, I could have just gone ahead and canceled those out and not rewritten them. Anyways, times 2x times the quantity x minus 3 over x plus 1 times x minus 1. So that's the biggest thing on these, pretty much like a multiplication problem. Just got to remember to do that reciprocal property. All right, so those are going to cancel, x plus 1 and x plus 1. There's no other 2x. There is an x minus 3, though. So what we're left with in the numerator is going to be, looks like just a 2x. And then in the denominator, we just have the x minus 1. All right, so then we want to look for our restrictions here. And then, so for this one, we want to kind of look at this step right here. So we have -4, +3, and plus or minus 1 that x can't be. -4, +3, and plus or minus 1. Okay, so that's just a few of the problems worked out for you. The rest will be done on the notes. And if that's not enough for you, same thing as before, just hop on Monday's Zoom meeting and we'll talk more about it there. All right, guys, good luck.